Okay, so this is going to be a quick video looking at some of the new content that's just been added to the IGCSE 0580 Cambridge syllabus. In particular, these three things here. So deriving and solving simultaneous equations involving one linear and one quadratic, expanding the products of algebraic expressions with more than two brackets, and discriminating between maxima and minima by any method, and the method we'll look at is completing the square. So those three things we'll have a look at in this video. The first one, simultaneous equations with one linear and one quadratic. They can ask this in a couple of different ways. If they're being nice, it could be something like this. We've got y equals 3 minus x and y equals x squared minus 3. We can't use probably the standard method that you've been taught, as in well, actually this one we could, where we add or subtract. A lot of the times we can't do. It's actually easier for all of these to do substitution. So we'll do these ones with substitution. We've got y equals 3 minus x, and we've got y equals x squared minus 3. Well, if y is equal to this thing and y is equal to this thing, then we can just say that in that case 3 minus x must be equal to x squared minus 3. Y is equal to that, y is equal to that. Therefore, those two things must be the same. So straight away, I've got rid of y. So this is like we're substituting rather than eliminating. So 3 minus x is x squared minus 3. It's now just a quadratic. I rearrange it. I notice I've got an x squared. My guess is always that I'm going to rearrange it to get a quadratic. So I make a quadratic equal to 0. 0 equals x squared plus x minus 6. You're normally going to be able to factorize. I think almost always they're going to be relatively straightforward to factorize. So I factorize it out, x minus 2, x plus 3. Let's check that works. Minus 2 times 3 is minus 6. Minus 2x plus 3x, yeah, gives us plus x. Therefore, I get two answers. X is 2 and x is negative 3. I've not quite finished because I also need to find out the y values. So for each of these x values, I'll get a different y value. So I just, same sort of idea as normal simultaneous equations. I see what happens. Well, when x is 2, I can stick x is 2 into whichever equation I want. Let's stick it into the first one. So when x is 2, y equals 3 minus 2, which is 1. That's one pair of solutions. X is minus 3, stick it into this one, y is equals 3 minus minus 3, which is 6, and therefore I've got my two sets of solutions. Okay, so it's pretty similar to normal simultaneous equations. Here's the second one. Same sort of idea, but it's a bit more tricky. I've got my simultaneous equation, x minus 4y is 2, and x times y is 12. The idea on this one is to make x or y the subject of one of these, and then I'm going to make a substitution. So in this case here, I've decided that I'm going to say, look, x minus 4y is 2, therefore rearrange this, take away the minus 4y, and bring that to the side, so we're going to add 4y, so we get x is equal to 2 plus 4y. So I've rearranged that first equation to get this thing here. The reason I've done that is I can now make my substitution. I know that x times y is 12. Well, if x is equal to 2 plus 4y, I can then say that therefore I've got 2 plus 4y times by y is equal to 12. That's this step here. So the idea is that I've got rid of the x. So now I've just got an equation just in terms of y. I can now expand it out, 2 times y and 4y times y. I get this equation. Same as before, rearrange it to get a quadratic. Make it equal to 0. A bit of a trick here, I can divide everything by 2, so it's going to be slightly simpler to factorize. It's a bit, still I've got a 2y squared, there's various methods. The correct answer, again, different ways you could do this. You could use a quadratic formula if you're not sure, but one is going to be 2y, one's going to be y. If I do minus 3 times 2, I get the minus 6, minus 3y plus 4y, yep, gives me y. So that's the correct factorization. What makes these brackets 0? 2y minus 3, or y plus 2. Therefore, this equation gives me y equals 3 over 2. And this equation here, or this part here, will give me y is minus 2. Therefore, I say, well, when x is 3 over 2, or 1.5, what is the x value? When y is 1.5, stick it into here. X times 1.5 equals 12. If I rearrange that, I get x is 8. And then the same one, if y is minus 2, stick it in here. Something times minus 2 is 12. Therefore, I get x is minus 6. Okay, and then the last one and this one. This is probably the most difficult one. This would definitely be an A-star question. The perimeter of a rectangle is 16.2, area is 16.1. Find the lengths of the sides of the rectangles. This is probably about the limits of what they could ask you. Let's start by doing a little sketch, which is this thing here. So I've got it's my rectangle, that's an x, that's a y. Area is 16.1, therefore x times y is 16.1. And I also know that x plus y is 16.2. I'm going to divide that by 2, so I'm going to get x plus y is 8.1. So I've got two equations. There's one equation, and there's my second equation. Okay, now I've got my two equations. It's going to be very similar to that last question. Again, there's different ways of rearranging it. I'll do the same ones before. So I basically said that x, I'll rearrange this one to get x on its own. X is equal to 8.1 take away y. So I've now got x on its own. I can now make the substitution into here. So x is 8.1 take away y. So replace that there. So therefore 8.1 take away y times by y is 16.1. Expand out your brackets. I've got 8.1y minus y squared equals 16.1. Rearrange it to get my quadratic. There we go, y squared minus 8.1y plus 16.1. Okay, this one's a bit more difficult. If I was faced with this one, I think I would just use the quadratic formula. Hopefully you know the quadratic formula. Minus b plus or minus square root of b squared minus 4ac all over 2a. Stick in your numbers. You should get an answer of y is 4.6 or y is 3.5. Once you've got those two answers, you're going to do the same as before. So when y is 4.6, you need to stick it back into one of these equations. Stick it into this one if you want, and you find out x is 3.5. If y is 3.5, stick it into one of these equations. Again, this time you get x is 4.6. And obviously, you'll notice this time it's the equivalent answer, isn't it? Basically one side of the rectangle is 4.6, one side of the rectangle is 3.5. Okay, so that's the first one. That's simultaneous equations. They can be quite difficult. Certainly can get up to A-star questions. This is the second one. Again, this would definitely be at least grade A sort of question. We're expanding out triple brackets. First sort of one could be this one. We've got an x bracket x plus 2 bracket x plus 4. First off, what you can't do or what you shouldn't do is multiply everything. So you don't do x times all of the x plus 2 and x times by all of x plus 4. You just do one bracket at a time. Okay, so you can just do x times by x plus 2, get your answer, and then multiply that bracket, the new bracket, with the x plus 4. So don't multiply every single thing by x. You get too much. And if you want to see why that is, if I said 3 times 4 times 5, that isn't the same as 3 times 4 and 3 times 5. You wouldn't do that. You'd do 3 times 4 first, and then you would times the answer by 5. Okay, so let's actually do it. So all I've done first is let's just work the first bracket out. X times x and x times 2 is x squared plus 2x. And then I've still got the x plus 4 here. Now I've got a double bracket, so I do the usual thing. The only difference is I've got an x squared. So x squared times x is x cubed. X squared times 4 is 4x. 2x times x, 2x squared. 2x times 4, 8x. And that's it. And then obviously simplify it. In this case here, I've got an x cubed, I've got 4x and 8x, I've got 12x, and I've got a 2x squared. Okay, a bit more difficult. They could give you 3 brackets without just an x here, but a double bracket and then another bracket after it. We're going to do the same thing basically. We'll just work out one of the double brackets first. It doesn't actually matter which one you do. Let's just work from left to right. So we'll do 2x plus 3 and x plus 2. Work out what does that give us. 2x times x, 2x squared. 2x times 2 is 4x. 3 times x is 3x. 3 times 2 is 6. And then simplify that. That's a 2x squared. I've got a 7x and I've got a 6. And now I've got to do the same thing. So I've now said that this double bracket here is 2x squared plus 7x plus 6. I've still got the x plus 4 hanging around here. I'm now basically going to expand everything, times everything by everything else. We follow the same idea. It's sometimes useful to kind of draw lines to what's multiplying by what. Let's start with 2x squared. We've got 2x squared times x, 2x cubed, 2x squared times 4, 8x squared, 7x times x, 7x squared, 7x times 4, 28x, I got bits missed. And then the last one, we've got 6 times x is 6x, and 6 times 4 is 24. So you follow the same idea as you would with the double bracket. And then the only thing that's left to do is to try and simplify it. If I simplify all this together, I get a 2x cubed, I get a 15x squared, I get a 34x, and I get a 24. Go on, let's just do one last one for the double and triple brackets. Here we go, x plus 4 cubed. First off, they're just checking that you know that x plus 4 cubed means x plus 4 times x plus 4 times x plus 4. So as long as we know that, we're okay. Let's work out an x plus 4 times an x plus 4. X times x, x squared, x times 4, and then 4x, x times 4 is 4x, so we've got 8x, and then 4 times 4 is 16. I mean, this one just show you it doesn't actually matter which way round you do it. So this time I worked out this side. So I've got the x squared plus 8x plus 16. I said that that's the same as the x plus 4 and the x plus 4 here, and I've left the x plus 4 on the left hand side this time. Like I said, it doesn't matter. We do the same idea for both of them. So I've now got this, and I now do the same thing. I've got an x times x squared is x cubed, x times 8x, 8x squared, x times 16, 16x, 4 times x squared is 4x squared, 4 times 8x, 32x, 4 times 16, 64. And again, I simplify it out. X cubed, 12x squared, 48x plus 64. Okay, so again, it would tend to be a grade A, possibly A star question. This one, I mean, it's worth just mentioning this one because actually this isn't as difficult as it looks. What you definitely don't have to do is expand out all this, and that would take a very long time, and you can do this in a much quicker way. Basically, they've said we can already factorize. They've actually factorized part of it for us already. They said it's some number of x plus some number, and then the other double bracket is an x minus 3 and an x plus 1. And we just need to find out what a and b are. The really simple way of doing this is to go, look, the x cubed term is going to be happening when I do this times this times this. That's the only bit that gives me the x cubed. I've already got an x and an x, that's an x squared. X squared times some lot of x gives me a 3x cubed. Well, therefore, a must be 3. 3x times x times x. There's where my 3x cubed is going to be. So straight away, without doing anything, I know that a must be equal to 3. So that's it. A must be 3. 3x times x times x. That's where the 3x cubed is going to have to come from. I've now got this bit here. I've got 3x plus b, and then x squared minus 2x minus 3. The next bit is I do the opposite bit. I now look at just the number, and I've got a 6. I've got a 6 here. I've got, how do you get the number? It's going to be the number, and then the number, and then the other number. Those three things times together, and then see what that gives us. Well, minus 3 times 1 is minus 3. Minus 3 times something to give me 6. Therefore, b must be minus 2. Minus 2 times minus 3 times 1 gives me 6. Okay, so what you don't have to do is expand out all the brackets. Try and use a little bit of logic to work out the missing numbers. Okay, and then the last one let's look at is this idea of discriminate between maxima and minima by any method. That's maximum points, minimum points. We'll just look at using the complete the square method. Just a super quick recap. This is the sort of idea when we've completed the square. If it's in the form x minus 3 squared plus 2, that would have the vertex at 3, 2. So you see, it's basically the opposite sign to whatever's in here, gives me the x coordinate, and this just gives me the y coordinate. Okay, and so equally, this one, x plus 4, opposite sign here would be minus 4, so that's the x coordinate, and then this gives me the y coordinate, so minus 3, so that's the vertex. And you can see that both of these would be the minimum points for this one. And then the general idea is if the number in front of the bracket is negative, you're going to get this sort of shape here. So then you're going to get the maximum point. So for example, if I had this one, y equals minus 2 bracket x minus 3 squared plus 4, it's the same as before for this bit. The opposite of this, a negative 3, the opposite of negative 3 is 3. That gives me the x coordinate. 4 gives me the y coordinate. That's all the same. But this bit here, because it's negative, it tells me that it's going to be flipped. And it's going to be like this, so it's going to be a maximum. Okay, so let's actually look at some questions on that. Here's the first one. X squared plus 4x minus 8 can be written in the form of this. Find the values of p and q. Okay, basically the trick on this one is to look at the number of x's. We've got 4x. We're going to divide it by 2. That's kind of the trick. We also divide it by the coefficient of x. The coefficient of x is 1. So 4 divided by 2 divided by 1, it just gives me 2. That tells me that I've got an x plus 2, that's the number I've just found, squared. So it's going to be something like that. Let's actually probably write this and make it slightly easier to follow what to do next. Once you've got this, probably the easiest thing to do is to now say, well, what would that give me? If I expanded this out, I'd get an x squared plus 2x, so plus 4x plus 4. That's what I get at the moment. Okay, if I expanded this bracket out. Now remember, what you're supposed to be getting is an x squared plus 4x minus 8. You'll notice the x squared and the 4x is all correct, but at the moment I've got a plus 4, and I'm supposed to get a minus 8. So you say, well, what can you do to this thing here to get to minus 8? Well, if I take away 12, then it'll be equivalent. So basically, if I take away 12 from this, if I do 4 take away 12, I do indeed get minus 8. Okay, so therefore my final answer is x plus 2 squared minus 12. And the question is not asking us to, but if we wanted to find out the coordinate of the vertex, so this is a plus 2, therefore the opposite is minus 2, and then minus 12 like that. So that's the coordinate of the vertex. That would be a minimum point because the x squared is just positive here. Okay, so let's have a look at another one. Same sort of idea. We've got x squared minus 9x plus 12. Divide minus 9 by 2, and then divide it by the coefficient of x. Minus 9 divided by 2 gives me minus 4.5. And then again, I start with this, just this first bit here. So I start with x minus 4.5 squared, and then I see, well, what would happen if I expanded this out? If I expanded all this out, I'd get an x squared minus 4x minus 4. I'd get a minus 9x. Minus 4.5 times minus 4.5 would be 20.5. So you can see that's what I get if I expanded this out. I've got the x squared correct, I've got the minus 9x correct, but I've ended up with 20.25. I'm supposed to get 12. How do you get from 20.25 to 12? Minus 8.25. So there we go. So complete the square form is this thing here. Okay, and again, if you want to just kind of visualize what that is, that's telling me there's a minus 4.5. That gives me x coordinate of 4.5. Minus 8.25 gives me the y coordinate of minus 8.25. That's what it looks like. And again, the x squared term is positive. Therefore, it's going to look like this. Therefore, it's going to be a minimum point. Okay, here we go. This is another question. This time I've actually said find the turning point by completing the square. So actually telling us what to do for this one. But we follow our method as before. I go, well, 4 divided by 2 divided by 1 gives me 2. So it's x plus 2 squared. And then say, well, what would that give me? That would give me an x squared. That would give me 4x. That would give me 4. Expanding out this bracket. That's what I've got. I needed to have a minus 3. So how do you get from plus 4 to minus 3? Taking away 7. So therefore, this is the complete the square form. Again, what's it going to look like? The plus 2 tells me the x coordinate is minus 2. Minus 7 tells me the y coordinate is minus 7. Therefore, minus 2, minus 7. That's what the turning point is. And again, it's going to be a minimum point because x squared is positive. Okay, you've got 2 left. Here we go. These are the more difficult ones. Again, definitely A-star questions. 2x squared plus 8x plus 7. Again, in this form here. Then I need to find out the coordinates of the vertex. Then find out it's a maximum or minimum. I'm going to follow my method as before on this one. I start by looking at 8, divide it by 2. This time I divide it by 2 because the coefficient of x squared isn't 1. So 8 divided by 2 gives me 2. So my general form is 2, because I've got 2x squared, bracket x plus 2 all squared. And then I need to find out what this missing number is here. So to do this one, let's actually work out what x plus 2 squared is. That would give me an x squared plus 4x plus 4. I'm timesing everything by 2 from here, which gives me a 2x squared plus 8x plus 8. As before, I've got the 2x squared, I've got the 8x, but at the moment I've got a plus 8. I'm supposed to have plus 7. How do you get from plus 8 to plus 7? Take away 1. So therefore, that's the complete square form. What's that going to look like? Same as before, this plus 2 gives me the x coordinate of minus 2. Minus 1 gives me the y coordinate of minus 1. That's what it looks like. the x squared term is positive, therefore it's a minimum. Okay, and then the very last one could be this one. I mean, this time I've put a minus x squared in, so let's actually see how that one is slightly different. Same idea as before. I'm going to go, right, there's a 6, divide it by 2, which is 3. Then divide it by the coefficient of x squared, which is minus 1. So it's going to be x minus 3 all squared. And I need to stick the negative on the coefficient of x. I need to stick that outside as well. So I've got minus bracket x minus 3 bracket squared. And then again, the question is, what is this missing number here? Expand out this bracket here, just leave the negative outside for a minute. X times x squared, I've got minus 3x is minus 6x, minus 3 times minus 3 is 9. Then expand out with the negative, minus times x squared, minus times minus 6x, and minus times 9 is this. Again, that's what I've got. I'm supposed to have a plus 3. I've got a minus 9. How do you get from minus 9 to plus 3? You plus 12. Therefore, that's to complete the square form. And then again, what does that look like? The minus 3, the opposite sign to minus 3 is positive 3. That's the x-coordinate. The plus 12 tells me the y-coordinate. Now I look at the negative outside. Because this is negative, it's flipped the graph. Therefore, I've got a maximum point here.